please copy this down, and if the heading doesn't make sense, we're going to talk about it in just a second. Solving nonlinear polynomial equations. Please copy that in your notes. Solving nonlinear polynomial equations, lesson 9.3, and be sure and include today's date, okay? Now, like I say all the time, I move fast. I expect you to pause the video as you need to. Alright, here we go. Before we get started, I need to comment on the sentence above, right here, and also on the heading, alright? So let me make a couple of comments. First, the sentence above. It says we're going to learn how to solve polynomial equations that have a degree higher than 1. Now, if you think about that for a second, that means we're going to solve polynomials that have a degree of, well, anything higher than 1. So we're going to solve second degree, third degree, fourth degree, fifth degree, so on and so forth, okay? Now here's the thing. You might not realize this, but guys, students, dudes, we've solved second degree equations already. Let me refresh your memory. We've solved those. What are they called? Remember those? Do you remember how we solved them? We used a method called what? Complete the square. Come on, guys, remember that? We also use this method. Remember that? You had nightmares about this. Remember the quadratic formula? We also solved these by using the what method? Do you remember? You guys are like, wow, I've forgotten this. Yeah, we got a lot of work to do before your final exam at the end of the year. Okay, a lot of work to do. Now remember, you can use the square root method when your quadratic equation does not have an x term. So if it looked like this, with only an x squared and a constant term, you could use the square root method, okay? However, if it has an x term, then you can use this method or this method. So we've already learned how to solve second degree polynomial equations. We just called them what? Quadratic equations, okay? So when I say we're going to solve equations higher than 1, that includes quadratics. However, we're going to learn a new method, so now, contain your excitement, we're going to add another method to your list here of solving quadratic equations. So we have solved quadratic equations before, understand that, okay? Alright, moving on. Next, heading. Now, why did I use the phrase nonlinear? Because guys, again, students, guys, dudes, an equation like this, if I asked you to solve that, that's a linear equation because the degree is what? 1. So when I say we're going to solve equations that have a degree higher than 1, that means nonlinear equations. Because linear equations have a degree of what? 1. And we're not solving those. We're solving problems that have a degree higher than 1. So in other words, they're nonlinear. Okay, that's why I use the words nonlinear. Understand that. So it's all the same thing, okay? We're solving equations that don't have a degree of 1 higher than 1. We're solving equations that have a degree higher than 1, or you could also say nonlinear polynomial equations. It's all the same. Alright, moving on. Now, having said all that, let's get started. The method we will be using to solve these equations today is called the factoring method. Got it? Factoring. Now you're seeing one of the reasons we've learned how to factor. Now you're understanding why I spent 1, 2, 3 days on factoring. You have to understand this. Here are the steps that you need to use when solving polynomial equations that are not linear, or in other words, they have a degree higher than 1. Here are the steps. Please copy these down. Step 1, move all the terms to one side and simplify. Step 2, factor one side. Step 3, take each factor that has a variable in it, set it equal to 0, and solve. Now I'm going to move on. I'm sure you have to pause the video and copy those down. Now, you know what, guys? There really isn't anything more to say. We just need to start solving these things, okay? So here we go. Let's take a look at 1, 2, 3, 4, 5. 5 problems, okay? Here we go. Let's solve this equation. Well, step 1 is move all of the terms to one side, okay? So it really doesn't matter. Personally, for me, I'm just in the habit of moving everything to the left side. That's just how I do it. You are more than welcome to move everything to the right side. It doesn't matter, okay? So bring the 48 over x squared and make it negative. There. That was really hard, wasn't it? Piece of cake. Step 1 is done. Step 2 is factor one side. Well, obviously you're not going to factor this side. It's the 0. So factor this side. So what I'm going to do is I'm going to come down here and factor it. I'm going to put it back up here. So here we go. We just learned how to factor a bunch of these. Are you ready? Step 1, pull out what's common. What goes up to 3 and 48? 3 does. 4x's and 2x's. How many can I pull out? 2. What am I left over with? X squared minus 16. Let's see if that's right. 3x squared times x squared, 3x to the 4th. 3x squared times negative 16, negative 48x squared. So this, which is right up here, factor down to this right here. Got it? So when I tell you to factor one side, that's what you do. And there it is. So I factored the left side. Everybody got it? I took this and I factored it. Back it up and watch it again if you need to. Now, step 3, take each factor that has a variable in it and set it equal to 0 and solve. Well, when I say factor, I'm talking about each part of the factorization. In other words, here's a part, and here's a part right here. Now, sometimes one of those parts will not have a variable in it. Let me say that again. Sometimes these parts right here will not have a variable in it. If that's the case, just ignore it. Mr. Arrow, I don't understand what you mean. Relax. We're going to do an example later in which some of your factors do not have a variable. I'll show you then what that means, okay? But for right now, understand I've got this part to my factorization, this part to my factorization, and they both have a variable. So what does step 3 say to do? Take each factor or part that has a variable, set it equal to 0 and solve. So here we go. Take this, set it equal to 0 and solve. Take this, set it equal to 0 and solve. There I go. Guys, I know it's a little confusing. You're like, whoa, dude, but listen, it's not that hard. Just follow these 3 steps and you'll be fine, okay? Now, by the way, well, let me continue on. I'll come back to that thought in a second. Okay, so I take each group and set it equal to 0 and solve. How would you solve this? We know how to solve this. Divide both sides by 3. 0 divided by 3 is 0. And now take the square root of both sides. The square root of x squared is x. And the square root of 0 is plus minus 0. Of course, with 0, you really don't need to put the plus minus, so 0. Now let's try this problem. Bring the 16 over and make it positive. Take the square root of both sides. The square root of x squared is x, and the square root of 16 is, don't forget, your positive negative. There we go. We did it. We have 3 answers. By the way, let me give you a little tip. Whatever your degree is, you will never have more than that many answers. So my degree is what? This equation is a 4th degree equation, right? Well, there's no way you'll have 5 answers. You will have 4 answers or less. Okay? So you'll have 4 answers or less. We have 3 answers. So my answers are 0, 4, and negative 4. There we go. We did it. Now, I want to point something out to you guys. Mr. Earhart, how in the world, why, how in the world can you just take each group and set it equal to 0 and solve? Well, I'm glad you asked that question. See how I have a group here times this group here? Let me ask you a question. If this group became 0 right here, I don't care what this group here is. The entire equation would become 0 because 0 times anything is 0. Or if this entire group right here became a 0, I don't care what this group over here is. Anything times 0 becomes 0. So students, think about it. That's why I can do this. That's why I can take each group and set it equal to 0 and solve, because if I make this group become what? 0, then the whole side becomes 0, which is what I want, because I want it to equal 0. If I can make this group become 0 or equal 0, that's good, because if this group becomes 0, then the whole side becomes 0, which equals 0. Now, some of you just said, holy cow, I am lost. That's okay. You don't have to understand my explanation. I want you to, but you don't have to. What you do have to know are these 3 steps right here. You have to be able to move all the terms to one side and simplify. Factor one side, and then take each factor that has a variable and set it equal to 0 and solve. If you can do those 3 steps, you'll be fine. So let's try 4 more problems and see if we can maybe eliminate any confusion that you have. Okay, step 1, get all the terms on one side and simplify. Now, guys, to me it's common sense. Maybe I should have put this in my steps. Maybe you should add this to your steps. Write in standard form. To me that's common sense. I never want to try to factor something that's not written in standard form, but if you feel like you need to add that to your notes, then feel free to, okay? So I'm going to bring my 14x cubed over. When I do, I'm going to put it next, because it's an x cubed. And then my 24x is next. Like that, okay? So there we go. I brought the 14x over. I made it negative 14x cubed, and notice I put it next because I want my highest degree first, my highest exponent, then my next, down to my last one, okay? Now here we go. Step 1 is completed. There should be no questions on that. Move all of your terms to one side. I picked this up and I brought it to the other side. Piece of cake. Step 2, factor. Okay guys, we can factor this. Let's bring it down here. We can factor this. I'm going to forget for a second that I'm dealing with an equation, and I'm going to factor this. So let's factor this. We know how to factor this. Step 1, pull out what's common. 2, 14, 24, pull out a 2. 5x is 3x is 1x, pull out an x. And I'm left with x to the 4th minus 7x squared plus 12. Let's check it and see. 2x to the 5th, negative 14x cubed, positive 24x. There we go. So I pulled out what's common. Now what are you left over with? A trinomial. Okay, does it have a late coefficient of 1? Yes, it does. That's the easy kind. But hold it, don't forget to check this. Is this exponent here twice as big as this exponent here? Yes, it is. That's very important. If that doesn't exist, you cannot factor it. Let me say that again. If this exponent here is not twice as big as this one, you cannot factor it. Now, I have a late coefficient of 1. So that's the easy kind. What 2 numbers when multiplied together give me 12? When added together give me negative 7. Well, look at that. What's a negative 3 times a negative 4? Positive 12. When you add these, what do you get? Negative 7. But hold it. Here's what you guys are used to doing. You're used to going like this. X minus 3. X minus 4. And that's not what you do, because this middle term right here is an x squared. Because that's an x squared, then you put x squared minus 3, x squared minus 4. You always do that. Whatever this variable is right here, don't worry about that number. Whatever this variable right here is, that's the variable that goes here and here always. Please don't forget that, okay guys? Alright, now, I did it. Oh no, I didn't do it. I can factor some more. Do I have perfect squares or perfect cubes here? Neither one. But look, I've got perfect squares here. That's a perfect square. That's a perfect square. And my first term is positive, my second term is negative. So guys, I can factor that last parentheses some more. Sorry guys, but I can't. This parentheses here can be broken down into 2 little parentheses. Square root of x squared, x. Square root of 4, 2. Make one positive, make one negative. There we go. So I finally did step 2. I took this entire side right here, and I factored it down to this. Well, we got our work cut out for us, don't we? Alright, here we go. Let's go this mess that I have here. And now let's bring this up to here. And there we go. So step 1, I moved everything to one side. Step 2, I factor this. Man, look how many groups I got. 1, 2, 3, 4. Do they all have a variable? Yes, they do. So I take each group and set each group to 0 and solve. These are fun, aren't they? Just kidding, a lot of work. Okay, 2x equals 0, divide both sides by 2, and x equals what? 0. Over here, bring your 3 over and make it a positive 3. X squared equals 3. Take the square root of both sides. The square root of x squared is x. And the square root of 3, I don't have that worked out yet. But let me grab my, I don't have my graphing calculator. I got this old cell phone with me. Let's see if that'll work. I apologize. Give me about 2 seconds here. Okay, the square root of 3 is 1.73, but don't forget your what? Plus minus 1.73, okay? Because you took the square root of both sides, but the plus minus. Here, bring your 2 over and make it a negative 2. X equals negative 2. Here, bring your 2 over and make it a positive 2. X equals 2. So write out your final answer like this. X equals 0, comma, positive negative 1.73, comma, and then you have a positive and a negative 2. Just write it like this if you want to save time. Positive negative 2. Hey, we got 5 answers. 1, 2, 3, 4, 5. 5 answers. What was the degree of this equation? 5. So you're allowed to have 5 answers or less, and we're good. Well, Mr. Error, what if I get 6 or 7 answers for a problem like this? That's impossible. You've made a mistake somewhere. Okay. All right, there's your answers. Let's try another one. Come on. Here we go. Okay, step 1. Move all the terms to one side and write it in standard form. So 3x cubed plus 7x squared minus 12x minus 28. Bring the 28 over and make it negative. Now step 2, factor this. So we're going to factor the left side. We're going to factor it, okay? So here we go. Step 1, you guys know how to do this. Just forget this problem for a second. Don't even worry about it, okay? Pretend you're back into your factoring days, factoring lessons. We're just going to factor this. Step 1, pull out what's common. There's no number that goes to 3, 7, 12, and 28. Does every term have an x? No. So there's nothing I can pull out of this whole thing. So look at your first 2 terms. What can I pull out? Well, nothing goes to 3 and 7 evenly. However, I have 3 x's here and 2 x's here, so I can pull out 2 x's. And I'm left with 3x plus 7. Okay? X squared times 3x, 3x cubed, x squared times 7, 7x squared. Now, look at your last 2 terms. Whenever this first term here is negative, you pull out a negative sign. What goes into 12 and 28 evenly? 4 does. Is there an x in both terms? No. Now, whenever there's a negative sign here, I just tell you to copy this over and see if it works. If it doesn't work, if I take this negative 4 and multiply it through and I don't get this right here, then you can't factor it, okay? So how would you solve the equation? Don't worry about that. I'm not going to give you any like that, okay? We're going to get to those later. But for now, they're all going to be factorable. Let's check and see. Negative 4 times 3x, negative 12x, negative 4 times 7, negative 28. So everything's good. So I write my matching parentheses once. And I write my other parentheses, x squared negative 4. Now maybe I'm done, maybe I'm not. Do I have perfect squares or perfect cubes here? No. But here I have perfect squares, and this is positive, and this is negative. So I can definitely factor the last parentheses again. Remember, when you're dealing with perfect squares, you write 2 little parentheses. Square root of x squared is x. Square root of 4 is 2. Make one positive, make one negative. And there we go, we did it. We took this expression here, and we factored it down to this right here. Oh, why'd I do that? There we go. Can I say something real quick, students? It does no good to factor an equation unless one side has a 0. Well, I shouldn't say it never. Most of the time, it does no good to factor an equation unless one side is equal to what? 0. That's always the first thing you want to do, step 1. Move everything to one side so that one side is equal to 0. Okay. Now step 2 is completed. Now we take each group that has a variable. This group has a variable. This group has a variable. This group has a variable. So I take each group, set it equal to 0, and solve. Bring the 7 over and make it a -7. Divide both sides by 3 and I get -7/3. Bring a 2 over and make it a -2. X equals -2. Bring the -2 over and make it a +2. X equals 2. So there we go. For this here, you can put -7/3, -2 1/3, -2.3 repeating. I don't care. All of those are fine. So X equals -7/3 and +2. How many answers do I have? How many answers do I have? 1, 2, 3. What's my degree? 3. Now, remember, just because you have a degree of 3 does not mean you're going to have 3 answers. You should have 3 or less. Remember, the first problem we did was a degree of what? 4. Yet we only had how many answers? 3. Okay? So, I'm not saying you have to have that many answers, but what I am saying is you will have that many answers or less. You will never be higher. You will never have more answers than what the degree is. Okay? Alright, 2 more and we're finished. Step 1, pull out what's common. I'm sorry, that's incorrect. Step 1, get one side equal to 0 or move all the terms to one side. That's done for you. Step 2, we're going to factor this. So here we go, let's factor this. And then we'll come back up to the equation later. Okay, step 1, pull out what's common. Well, there's nothing common. There's not an x in every term, and there's no number that goes into 9, 12, and 4 evenly, so I can't pull anything common out. Step 2, what am I left over with? Trinomial. Do I have a lead coefficient of 1? Snap, I don't. I wish I did. So because I don't, it's one of the harder problems. Remember, I have to take this times this and put it over here. So 9 times 4 is 36. So what two numbers multiplied together give me 36? When add together give me a -12. Well, if I multiply those two numbers, I get a +36. If I add those two numbers, I get a -12. Now something else to check. Is this power here twice as big as this power here? Yes, it is, so we're good. Now remember, you don't put parentheses yet like this. Why not? Because we don't have a lead coefficient of 1. We have a lead coefficient of 9. So remember, we bring down our first term. We bring down our last term. And then we drop this out, and in place we put -6. And by the way, I messed up, and I'm sorry, guys. This first term is 9x to the 4th, okay? Now, right here in the middle is an x squared. So we drop this out, and we put what? -6 x squared. -6 x squared. Why x squared? Because your middle term is x squared. If this would have been x cubed, you use a 3. Okay, whatever that variable is, that's the variable you want to use here. Now, pull out what's common in the first two. Well, 3 goes into both those numbers, and I have 4 x's here and 2 here, so I can pull out 2 x's. That leaves me with 3x squared minus 2. Let's check and see. 3x squared, 9x to the 4th, 3x squared times -2, -6x squared. Now, look at your second two terms. There's a negative sign here, so pull out a negative. What goes into 6 and 4 evenly? 2. Is there an x in both terms? No. And then whenever you have a negative here, just copy this and see if it works. Just copy that and see if it works. It's a lot easier. -2 times 3x squared, -6x squared, -2 times -2, +4. So, you write your matching parentheses once, and then your other parentheses would be, look at that, the exact same thing. Pretty interesting. So there we go, I did it, guys. I factored this entire expression here down to this right here. So step 1 was to move everything to one side. That was done for you already. Step 2 was to factor, and we did that right here. And now step 3, take each group and set each group equal to 0 and solve. Now hold on a second. Why would I do that when the two groups are the same? I mean, it's a waste of time. You'll get the same answer out twice. So if your two groups are the same, you're welcome to go like this if you want. It does not bother me. You are welcome to do this if you want. But you understand you're solving the exact same equation twice. There's no need for that, okay, because your two parentheses are identical. So let's just solve this. Bring your 2 over and make it a positive 2. Divide both sides by 3. And now take the square root of both sides. If you take the square root of x squared, you get x. If you take the square root of 2/3, that's plus minus 0.81649. So 0.8165 is sufficient. You can round wherever you want to. So there we go. So we have a degree of 4, and we end up with 2 answers, which is fine. So there you go. Okay, let's take a look at one more. Then you guys can practice on your homework a little bit. Okay, last example. Step 1, move all of your terms to one side. So bring your 300 over and make it negative. Easy enough. Bring your 300 over and make it negative. Step 2, factor. Okay, let's factor this. We're pretty much factoring pros by now. We've done a lot of these. Step 1, pull out what's common. Well, 3 goes into 3 and 300. There's not an x in every term, so I cannot pull out an x. But if I pull out a 3, I'm left with this. Okay, it looks pretty good. Now what am I left over with? A binomial. Are they perfect squares? Yes, they are. One's positive and one's negative, so I'm going to put 2 little parentheses. Square root of x squared is x. Square root of 100 is 10. Make one positive, make one negative. There we go. I did it. So I took this entire side right here, and I factored it down to this. Now, here's what I've been waiting to show you since the very first time I gave these steps. Look at your steps, please. When it says, take each factor that has a variable in it and set it equal to 0 and solve, I told you that not every factor or every part is going to have a variable. And I told you I would give you an example of that, and finally I am right here. Here's your parts. 1, 2, 3. Does this part have a variable? Yes. Does this part have a variable? Yes. However, does this part have a variable? No, it's just a 3. So that's why you don't worry about that group. You just discard it. Don't worry about it. You only take the parts that have a variable and set them equal to 0 and solve. So this group, set it equal to 0 and solve. This group, set it equal to 0 and solve. This wouldn't help you at all if you took 3 and set it equal to 0. You can't do anything with that. It's not going to help you, okay? Alright, bring your 10 over and make it a negative 10. Here, bring your 10 over and make it a positive 10. And there's your answer. X equals positive negative 10. Now, I know what you're thinking. I know exactly what you're thinking, Mr. Earhart. We solved these problems before, and we did it a really fast way. We divide both sides by 3. And now took the square root of both sides. I know that. I'm well aware of that. I hope I didn't confuse you. I just wanted to show you that, yes, the square root method most definitely would have been the best method to use on this problem. But do you see how the factoring method still works? It works just fine, okay? Guys, what you need to do now is practice, so I hope that you will do that and work hard with your homework.